In this video, we're going to answer the question, is our function f of x, the given piecewise function that we have here, continuous at x equals -2? If it's not, let's state the type of discontinuity there. The three pieces of the puzzle that we need to have in order for a function to be continuous at the point that we're questioning is, in this case, is f of c, does it exist? Does the limit as x approaches c of f of x, does it exist? And then lastly, the two values that we find from 1 and 2, namely the limit of f of x as x approaches c and the value of f of c, do they equal each other? Those are the three things we have to satisfy in order for our function to be continuous at our point c, which in this case is -2. So let's start by answering, what is f of -2? Is that point, or is that value defined? When we deal with -2, the piecewise function that we have given here breaks it down to intervals of x is less than or equal to -2 and x is greater than -2. So when we're evaluating at -2, we're going to use this top piece here. So we have 2 times -2 squared minus 7, or 2 times 4, which is 8, minus 7 is 1. Okay? So our value at f of -2 exists, it's defined, so we're all fine and dandy there. Now, looking at the issue that is posed by looking at the limit of f of x, depending on which direction we are approaching -2 from, either from the left, coming from less than values, or if we're approaching from the right, coming from greater than values, we're going to have to use different pieces of our piecewise function to analyze the limit. So what we're going to need to do here is we're going to need to analyze the left-handed limit and the right-handed limit of this function and see if they equal the same thing to determine if our limit exists, and if it does, what value that returns. Okay, so when we're looking at the limit, I know it's going to drive me crazy. Get rid of that. So we're looking at the limit as x approaches -2 from the left of f of x. That's going to need to be concerning with 2x squared minus 7. And if we're looking at the limit as x approaches -2 from the right, we're going to need to deal with the piece of negative times the expression 3x plus 5. So we're going to analyze the behavior of these functions as x approaches -2 from the left on this piece, and as x approaches -2 from the right of this function. Okay, let's start with approaching from the left. Let's see where our x is and see what happens as we approach -2 from the left. As we approach -2 from the left, what this x squared value is going to return, this x squared is going to approach positive 4. As we get arbitrarily close to -2, we're going to get a value closer and closer to -2 squared, which is 4. Okay, so then as we look at 2 times x squared, this value, as x approaches -2 from the left, will also approach 8. Right? So that's what we're dealing with so far here. And then what we're getting is that as we're looking at x squared approaching 4, what it's going to technically do is it's going to approach 4 from the right. Right, because as we get closer and closer to -2, the values of that number squared are going to get smaller and smaller, but they're going to approach 4 from the right. And so looking at something in that same light, we're also going to get values of 2x squared that approach 8 from the right. Okay, so what does that mean? Well, we know that 2x squared is going to approach 8 from the right, and then we're going to subtract 7 from that. So our 2x squared minus 7 will approach, oh, misspelled that. Hold on, let me fix that. Will approach, that looks terrible. There we go, that's fixed. Will approach 1. And it will specifically approach it from the right as well. Okay? So that's what we have there. The limit as x approaches -2 from the left will be 1. Let's look at as x approaches -2 from the right of this piece. So now what we're going to do again is we're going to kind of work inside out. We're going to look at the thing dealing with x, anything added onto it, and then last we're going to deal with this negative here. So as x approaches negative 2 from the right, 3x will approach. Let's see what happens. As we get closer and closer to negative 2 from the right, we're going to have values that closer and closer approach 3 times negative 2, which is negative 6. And the way we're going to come at those is we're going to approach negative 6 from the right as well. Okay, and so now when we take into account 3x plus 5, since we're approaching negative 6 from the right, we're going to get some numbers here that are going to, as we get closer and closer to negative 2 from the right, we'll get closer and closer to negative 6, meaning this product will be closer and will approach negative 6. So at this point, 3x plus 5 will approach, I can't spell today, will approach negative 1 from the right. Okay, and so since as we get closer and closer to negative 2 from the right, this value inside the expression will approach negative 1. If we multiply this outside by a negative, this means that our limit, as x approaches negative 2 from the right, will be 1, and we'll actually be coming at 1 from the left, if that is any technicality or any cop-out. So let's go ahead and write that down just so we have that. We can reference it later if we need to. We'll approach 1 from the left. Okay, when we're analyzing one-sided limits, in order for our limit itself at x approaches negative 2 to exist, we know that the two limits have to agree with each other, the two one-sided limits, that is. In this case, they do, so this means that the limit as x approaches negative 2 of f of x equals 1, meaning that part 2 is satisfied. This limit exists, and it's 1. So seeing part 3, we ask, does the limit of f of x as x approaches c, does it match with the value that we get if we plug in our c for inside of f of x? And the answer is yes. We get 1 here, 1's the limit here. Number 3 checks out, so we get that f of x is continuous at x equals negative 2.